Now, this is a follow-up to the question above, which in this case we're asked to find the radius of the resulting helical path and the angular speed of the proton, and finally the pitch of the helix. So first off, we're going to figure out what the radius of the resulting helical path is, and to approach that we use the formula which we derived on our previous video to be equal to the radius is equals to the mass of the proton multiplied by the velocity on the z-axis divided by the quantity of charge of the proton multiplied by the magnetic field strength. And once you're able to figure out that the mass of the proton is 1.67 times 10 to the negative 27 kilograms multiplied by the velocity on the z-axis, because the velocity component in the z-axis is transverse or perpendicular to the magnetic field. This is actually equal to 2.00 times 10 to the 5 meter per second. This is divided by the quantity of charge, which is 1.6 times 10 to the negative 19 coulomb, times that of the magnetic field strength, which is 0.50 Tesla. So as a result, we get an answer for the radius of the resulting helical path is around 4.18 times 10 to the negative 3 meters. That is the radius. Now, if we're going into the next one, which is determining the angular speed, we know in this case that the angular speed is highly linked to the angular frequency, and by using the formula for the angular speed, what we recognize is that using the angular frequency, which is the small letter omega, is equal to the velocity on the z-axis divided by the radius of the helical path, we do know that we're going to use this relationship as well. In this case, is also equal to the quantity of charge multiplied by the magnetic field strength divided by the mass of that particular proton. So if you want to go through both methods, you can go through this one, but I will ideally go with this particular way of solving the problem, because technically speaking, we're not 100% sure what the value of the radius is, because it is not a constant. But in this part here, which we're focusing on, those are kind of constants based on the question, so we're going to play it safe and work with that. So in this case, we have 1.60 times 10 to the negative 19 coulomb multiplied by 0.5 Tesla divided by the mass of the proton, which is 1.67 times 10 to the negative 27 kilograms. So as a result, what we get for angular speed is around 4.79 times 10 to the 7 radian per second. So since we're able to figure that out for angular speed, which is based on the angular frequency, what we do next is to determine the pitch, that is the distance between two consecutive circles, and this depends on the vector that is parallel to the helical path or the magnetic field. Now, focusing on that particular particle in there that is traveling at that particular helical axis, and to approach that we use the formula v on the x-axis multiplied by the period. So to determine the period, what we use is actually period is equal to 2 pi over the angular frequency, which is also equal to 1 over the frequency. And what we do in this case, that this is also equal to 2 pi over the quantity of charge multiplied by the magnetic field strength, and all this is multiplied by the mass. So in this case, what we do is that we just go with this particular formula right here, and we actually get our resulting value to be 2 pi over 4.79 times 10 to the 7 radians per second, which is based on this particular formula right here, and then what we get is 1.312 times 10 to the -7 seconds. Now that in here we need to determine what pitch is, we actually multiply this value here by the velocity on the x-axis. So in this case we multiply our value, which is what we got in seconds, by the value on the x-axis for the velocity, 1.5 times 10 to the 5 meter per second. So as a result, what we get for our answer for the pitch is equal to 0.0197 meter. So that's about it for this particular video. Hope you're able to understand how to determine the pitch of a particular helical path, and also determining the angular speed in there, and also finally determining the radius of the resultant helical path. All the same, thanks for following me through this. Truly appreciate it. Hit a comment down below, let me hear your thoughts. By that way I can talk to you all later. Stay smart and believe in yourselves.